So this is where it's weird, because you're supposed to stand over there to speak, but the slides are over here, so it's a little hard to see it on the slides.
It is a weird room anyway, really. I mean, it's blocked off. You know, it's like part of that room, but they put this blocker up, and then they created yet another room by putting that blocker up. So this is like the front half of that room. Very strange.
Yeah. That's a way for pointer on our link. Read down. Well, I guess we might as well get underway.
Sure. Hello, everyone. Welcome to the Babel and/or Babel working group, depending on where you live in the world. It's Thursday afternoon. It's late, and we only have 2 rules. The first is you have to sign the blue sheet, and the second is don't snore. Okay? We don't care if you do much else, but don't snore and sign the blue sheets. So, while Donald is taking the sheets around, I'll just talk about the note well. I guess you have it on your slides, Donald, so I'll wait and let you cover that in just a second as you go through. Please read the note well, memorize it. There will be a test at the end of the working group meeting. Did you leave me a Coke?
No, it's mine. When we swap places, I fail to take it.
I thought you were telling me to have a Coke that's small.
It wouldn't hurt, no. Jeez, what is this taut chord feature? Anyway, okay, besides the note well, there's actually another, right.
It's trapped. I'm going to go this way. It's helpful.
Yeah, okay. Another slide here, which is about document reviews. So the way documents get improved in the IETF is by people reviewing them and commenting and getting those comments resolved. So if you want your documents to be improved and have people review them, you'll probably find that happening more if you review other people's documents. So it's kind of a reciprocal sort of thing. Here's the agenda. There are 3 presentations, and the slides are all uploaded for those. Does anybody have any changes they want to make in this and bashing the agenda and moving things around? We do need to have some scribes. So do we have a volunteer to take minutes and a volunteer to be a Jabber scribe? Okay, I guess we can have more than one. But it's go ahead. No, I don't think so. Oh.
I don't need it. This is like a hat.
You have to put it on your head.
Okay. Okay, Margaret Collins volunteered to take minutes. Excellent. So I want to just review the status of things a little bit. Oh, by the way, I'm Donald Eastlake with Huawei Technologies, and
Russ White with a very small hyperscaler you've never heard of.
Okay. And people coming to the microphone should say who they are. And there's even a little sign hanging from the microphone that says you should do that, which nobody ever notices. So nobody seems to want to have any changes to the agenda. This is the status of documents. There is one adopted document draft, which is the applicability draft. There's a draft, the RC 6126 BIS draft, which is in call for working group adoption, ending right now, actually, kind of. And there's been comments on the list favoring its adoption and none opposed. So is there anybody in the room opposed to adopting that draft? Seeing nobody, that's adopted as a working group draft. Authors should post a draft IETF Babel version of it.
So that was RFC 6126.
Yes, that is correct. There are a couple other drafts out there, and there are 3 RFCs from before the document, the experimental version. So you look at our charter, you can see our main task is to move things to standards track. In a few words. Yep.
Julius Krobacek, I think, as far as I understand the charter, that the first draft you cite in the related draft section is out of scope for us, and it's the source-specific routing draft that is in scope.
I believe that's correct. Yes, there's a mention in the. You can look at the charter with the work items. There's mention of source-specific routing, but the diversity routing is not currently there. But the draft can be changed as we get our earlier sort of higher priority goals completed, and if people are still want to move ahead, we can add other items later to the task list. So there are actually milestones. So we've accomplished the first 2 of these. The second one, I guess, should be green because we just did the working group adoption. So anybody has any question on the status? If not, I guess we can go ahead with the first presentation. So let's see, this is I just want to go to the, I'll put this thing in full view, under full screen.
Hello?
We have a control, if you want to have control, or I can
you
do
do
it.
it for
I
me?
can do it for you. Nice.
So hello, I'm Julius Krobacek, and I'd like to give a quick talk to speak about 2 things, just what I would like to see in this working group and what changes I'm proposing that this working group should make to the Babel routing protocol. Next, please. So this is a new working group. I'm extremely pleased.
Yeah, you can readjust that if necessary, or just take it out. Yeah. Okay.
Is that better?
Yeah.
Okay, so this is a new working group. I just cannot tell you how pleased I am that this working group exists. It's going to exist for some time, perhaps 3 months, perhaps 3 years, hopefully not 30 years. And right now, during the first meetings of this group, we will be establishing a tradition. Now, traditions are not cast in stone. They can be changed, but it's always easier to get it right at the beginning rather than trying to change it later. And so Babel has a community. It has a user community. It has a developer community. And I think that it is possible to establish a tradition that will be consistent with both the IETF tradition and the tradition of the Babel community. So one thing that is very much a thing at IETF, and I think it's particularly important for this group, is that work doesn't happen at face-to-face meetings. Work happens on the mailing list. The other thing, and that's also very much an IETF thing, is that working code is important. If it hasn't been implemented, well, it's a good idea, but it didn't happen. And finally, the goal, after all, is to have users and to have the users use the protocol. So we should be looking at what the users do. Okay, and there's a final point. I'll come back to that. Next, please. So work happens on the mailing list. Face-to-face meetings are a lot of fun. They're very useful in order to get to know people, to ease conflicts. But real work should happen on the mailing list. So that gives you a chance to read the document. In face-to-face meetings, you might not want to say, well, actually, I haven't read your document. Over email, you can always take the time to do it. So it makes the discussions more constructive. It's good for people who cannot travel. And I don't know if I'm allowed to say that, who cannot pay the outrageous IETF inscription fees. It's good for people who are not native speakers of English and who often find it difficult to follow at face-to-face meetings. It's important to let bad public speakers express themselves. Just because you're a bad public speaker doesn't mean that you're wrong, and just because you are a university lecturer and have 2,000 hours experience public speaking doesn't mean that you're right. And finally, email gives you a record. You can always go back to your email archives and say, well, actually, you did say that. You were wrong. Next, please. So that's something I would really like to see. If it's not implemented, it doesn't get into the spec. So if you're good at logic, the contrapositive of this statement is if you want it in the spec, you must get it implemented. Now, this doesn't mean that's not necessarily difficult. There are various ways of getting things implemented in Babel. The best thing is do it yourself. Because when you do it yourself, you suddenly realize, actually, this idea was really stupid. It doesn't work. It's impossible to implement. I'm solving the halting problem while doing that. Another way is to bribe Toke. I don't see Toke. Toke is over here. He accepts gold bullion in large quantities. Another way is to beg Marcus. Marcus is not bribable and not bullyable. Another way is to bully me and people who work together with me. And finally, and that's, I think, the bad solution, is to pay a consultant to do it. The problem with paying a consultant is that he'll do it even if it's a stupid idea. He's being paid to do it, so you won't know whether it was a good idea after all. Next, please. Okay, we have a user community, not a very large one, but it does exist. There are companies that rely on Babel. There are individual users. There are community networks that use Babel. And we have, over the last years, been very careful to do the things that the users want, rather than implementing stuff because we thought it was a really cool idea and nobody would ever use it. So I would like us to continue paying attention to the users. So if users are relying on something, either it's a good idea or they are trying to work around the lack of some good feature. If the users are doing something really stupid, it's not our role to tell them don't do that. It's our role to think why they are doing something stupid and what's missing and why they need to do something stupid. And if users are ignoring a feature that you think it's really cool, well, after all, perhaps the feature is not as cool as you thought it was. Next, please. Okay, finally, and that's something that is obvious but bears stating, Babel is not OSPF. Babel is not ISIS, and Babel is not even EIGRP. And the reason I'm mentioning that is that features are added, mechanisms are added to Babel because they are useful in Babel. And something I'm hearing quite often is helpful people telling me, look, you really should add this feature because in the my favorite routing protocol community, we found it really useful. Well, it has been found useful in a different routing protocol because that protocol has different dynamics. Babel does not necessarily have the same dynamics, and a feature that is very useful in ISIS might be completely pointless in Babel, or perhaps not. But Babel should be considered, every feature should be considered with respect to Babel. Next, please. Okay, so after this small bit of propaganda, I'll get a little bit more technical. So our charter, the beginning of our charter says what I understand as saying that we are to write a standards track protocol definition that is based on RFC 6126, the Babel routing protocol, and RFC 7557, the extension mechanism for the routing protocol. So the reason those are two RFCs is that originally, before I had any extensions, I knew I wanted to have an extensible protocol, but I didn't know what the extensions would look like. So when I was writing 6126, I just said, okay, this bunch of space is reserved for future extension. If you see data over here, just silently ignore it. And what the extension data would look like, I wasn't ready to specify at the time. And it's all only after we had done a few extensions, gotten a few extensions wrong, gotten other extensions, I think, right, that I was able to say, okay, put it like this has worked for 3 extensions. We are fairly confident that that's going to work. So those are 2 documents for historical reasons, not for logical reasons. They should be a single document, and that's what is in our charter. So RFC 6126 has a major version field. It's the second octet in every Babel packet, and it is 2. We have gone through 2 previous incompatible releases where we had found fundamental bugs in the model. We changed in an incompatible manner, and now we haven't changed, I think, for 4 or 5 years. We are at version 2. We have changed some things, not necessarily technically in a quite compatible manner, but globally the protocol has been stable and backwards compatible. Now, it's currently set to 2, and if you get a packet with a different value, you silently drop the packet. You ignore it. So you can be running over the same UDP port and the same multicast group, version 2 and another version, and version 2 nodes will be silently ignoring the packets they don't understand. So now we need to make a choice. Now it's a continuum, but I find it useful to present it as 3 discrete choices. The choice that I call small is, let's fix the obvious bugs. Let's reword the places where my English was bad. Let's integrate the document, and let's basically write down the same protocol. Medium consists in retaining major version 2 and doing something that is perhaps not quite technically compatible, but that interoperates with all existing deployed implementations. And option large is, let's say, okay, let's throw out version 2. Version 2 has served us well. Let's retire version 2, design version 3, call a flag day, perhaps provide some transition mechanism if it's needed, and say everyone now switches to version 3. Now, if I were a good politician, I would right now, say that I have no opinion about that I'm trying to be really balanced, and then try to subtly manipulate the working group to do what I want. But you have to be really good at that, because if you are not, you start thinking that you're able to manipulate your constituency and you end up leaving the European Union. So I'm not going to do that. Next, please. I am in favor of option medium. Retain the same major version. Make it at least possible to write an implementation of standard Struct Babel that interoperates with existing implementations, but do not limit ourselves to being strictly within the letter of RFC 6126. Now, keeping version 2 does limit us somewhat, but it does not necessarily mean that we cannot make any changes. We can say, okay, RFC 6126 allows this field to have values 1, 7, and 42. 7 is a bad idea. You're no longer allowed to send version 7, to send value 7. And if you receive 7, you're allowed to ignore it, but if you really want to deal with it, it's written down in 6126. We can do things like adding new TLVs. We can do things like obsolete existing TLVs by saying you're allowed to ignore it. By the way, the old definition is in 6126. And the main argument in favor of not bumping the major version number is that if it turns out to be a bad idea, we can always do it later. If we start working on a protocol that's compatible and then say, okay, that's really a problem for us, there's stuff we'd really like to do that we cannot do, we can always bump it. If we start working on an incompatible protocol, it will be very difficult to later decide it was a bad idea and we must go through the whole document and check all the bits that are going to cause trouble for backwards compatibility. So that is, to a certain extent, the conservative choice. Next, please. Okay, so what do we give up by not bumping the major version? So, of the good ideas that were suggested for a new version of Babel, one thing we won't be able to do is to add a mandatory bit to sub-TLVs. So the Babel extension mechanism uses a TLV, and within which you can have sub-TLVs. And if you don't understand a sub-TLV, you keep the data that you don't understand. You only ignore the sub-TLV that you don't understand. Okay? It's not recursive. You don't have sub-TLVs. You have a namespace of TLVs, a namespace of sub-TLVs. They are disjoint namespaces. And a mandatory bit would allow you to declare, if you don't understand this sub-TLV, ignore the whole TLV. It does have some useful applications, but the two applications that we have for that can be worked around by using either a new TLV number rather than a sub-TLV, because TLVs are ignored, or by using a new address encoding. I won't get into the technical details. The other thing we won't be able to do will be to take the metric, which is currently 16 bits, and set it to 24, 32, 64, so it's 128 bits. Okay, it's 16 bits. Now this can be worked around because Babel allows carrying multiple metrics. So that's the distance vector kind of multi-topology stuff. It's only the primary metric, the one that is used for loop avoidance, that is limited to 16 bits. So what you can always do is to set the primary metric to just hop count and use a secondary metric, which is a sub-TLV and can have completely free format. We actually have one extension that uses variable length metrics. So if the metric is a hop count, then this gives you 65,000 hops. And once we have a diameter, a network of diameter 65,000, I think we'll have other issues. And finally, we won't be able to clean up the packet format. Now, it's not that bad. In the words of one implementer, the packet format is not as horrible as you make it. And indeed, it's not quite horrible. There are a few things that I would like to change, like removing some fields, but that's actually a mixed thing, because the danger of cleaning up the packet format is that you might end up arguing about minor nits of the packet formats for years and years. So actually, I'm pretty relieved that we're going to avoid that. Okay, there are other things that have been suggested that I think are non-issues. They are not things that we would want to do. One thing that has been suggested is to expand TLV length to 16 bits. It's currently limited to 255 octets. That's plenty. This is a UDP-based unreliable protocol. It's not designed for carrying massive amounts of data. If you want to carry massive amount of data, I suggest you use FTP, for example, or BitTorrent. The other thing is there is no issue with the number of available TLV types. TLV type 255 is reserved for expansion of the TLV space using the standard technique of dumping 255 and then putting a 2-octet TLV type at the beginning of the body of the TLV. Next, please. Okay, so remaining interoperable doesn't mean that we cannot make changes that are technically incompatible. So some of the things are, according to me, pretty certain. I don't see why there should be opposition to those. So there is a router ID associated to every router. It's a 64-bit randomly drawn opaque thing, and no values of that are reserved. Toke is telling me that it would make implementation easier if he could use 0 to mark the lack of a router ID. That makes perfect sense. And while we are at it, we also reserve all ones because it looks more elegant that way. There is a mechanism called compression, which allows you to omit a bit of an IP address if it is earlier in the same packet. That's extremely useful. It has absolutely dramatic effects on the number of routes you can dump in a single UDP packet. It means that in a double stack network, where all nodes have IPv4 and IPv6 using flat routing, you use up about 24 octets on average for every node, for every address, sorry, for every route you advertise. So it divides roughly by half the amount of data you're pushing. But it is a little bit too loose. We have found that we allow compression in contexts where it is confusing. So we should tighten the compression requirements. And things that I'm not sure about, because we don't have any implementation experience, include, so hellos carry an interval from which you derive the hold time. Some people have suggested that interval equals 0 might mean I'm leaving the network. Please drop all routes that go through me. Currently, what we use is that we set the minimum value, which is 1 centisecond, 10 milliseconds, which means that you disappear after 30 milliseconds from your neighbors, which usually is good enough, but it might be more elegant to use value 0 for that. Dave and Toki have been taking every single opportunity to say you must define unicast hellos. So the protocol currently allows all the TLVs to go over unicast or multicast, and they have exactly the same semantics. It's very carefully to do that, and there is one exception. It is hellos. Hellos can only be sent over multicast. And there are good technical reasons for that, and that would mean defining a new TLV type for unicast hellos. There is a thing called address encoding 0, which is used for encoding wildcards. So they allow you to do things like to retract all routes that you've previously advertised in a single TLV, or to request a full route dump. And people have argued, and I'm pretty much convinced that's the case, that we don't need wildcards. We can get away without them. They're uselessly confusing. I'm a little bit uncertain. I don't know how useful there might be for debugging. In particular, the ability to take a full route dump from a node is pretty cool, but I'm pretty convinced that it's confusing enough to do away with it. And finally, there is one kind of request that I'm not sure is necessary in the protocol, and if we can get away with obsoleting it, that would be really good. Next. Okay, and of course, we want to do improvements. Now, I would like to limit as much as possible what happens in the base spec, but some people have suggested a mechanism for detecting router ID collisions. My take on that is that router ID collisions don't happen. It's a 64-bit space. You have a good random number generator. People tell me, and what if you don't have a good random number generator? And I say, la, 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 I haven't heard you. So if such a mechanism can be defined, I don't think it's a bad idea. I just don't see how to do that reliably and simply. And something that has been noted is that the RFC doesn't say enough about error handling. It says what you must do when you receive a well-formed packet, but it doesn't say what to do when when badly formed packets are received. So in some cases, you want to drop all the rest of the packet. In some cases, you want to skip to the next TLV, and that should perhaps be better specified. Next, please.
Excuse me?
Next, please.
Next slide, okay.
Okay, what about the extensions? Well, we have 3 mature extensions. One is in charter, and 2 are out of charter. So the chairs will tell me if I'm absolutely not allowed to speak about out-of-charter extensions here. But there is the source-specific routing, which is explicitly in charter. It is a reasonably mature extension. Unfortunately, we encoded it just wrong. We encoded it by using a new set of TLVs, and we should have realized that because the packet encoding is a mess. And so we tried to regularize the packet encoding without understanding that our mental model of what a source-specific route is wrong. We now understand that better, and I'm planning to take a completely new approach to source-specific routing, to submit it as an individual draft, and I think I'm going to that before I ask for adoption of the draft. And of course, implement it according to what I've said earlier. There is RTT-based routing that's out of charter, but it's a mature, stable, deployed extension. It's an extension that's deployed in production. It has been found extremely useful in a fairly narrow set of contexts. It's for overlay networks. I'm planning no changes at all to that. And there is radio interference over routing, which is the draft that Donald cited at the beginning. So that is out of charter, and I believe it's not ready at all. We need more experimentation. We do have an implementation, people are running it, but we don't have a good idea of how much it improves things. And so I think we're not ready. Next, please. Okay, security. I'm not going to speak about security. We will need to standardize a security mechanism. We have a security mechanism, that's RFC 7298 due to the NSFCN. I have heard other ideas for security in Babel. There is what I call Stenberg-style security. So Marcus Stenberg likes to design his protocol so that they push all data over unicast. And then he says, look, all the data is going over unicast. I'm going to use TLS. So that's a pretty nice way, not of simplifying the security aspects, but that of moving them to be the responsibility of a different working group. Well, if you have replay protection, why not use simply statically keyed IPsec? Why not? Or something else. I'm not at all a security specialist, so that is something I hope that security specialists will step up.
One of the things I think we have to agree to, my name's Margaret Cullen from Painless Security. One of the things I think we need to agree to, like before we pick an approach to security, is what threats we want to be able to protect against. There's a whole lot of good work on that was done for other routing protocols that we can probably, look at least and discuss. But the different things you're looking at there would protect against different things. And I think it's hard to say, like, well, which one do you like? Well, I mean, what are you trying to protect against? So I think we probably want to reach some agreement on that before we decide sort of what overall approach to take.
Absolutely. There is a whole set of trade-offs that frighten me in security work. One is what attacks are you trying to protect against? The other one is how flexible do you want your policies to be? And the third one is how complex are you willing to let your implementation become? Yes, yeah.
Justin Dean, NRL, Manny Working Group Chair. We just recently had a security TLV published for the packet format the generalized packet format, and it took a long time getting there. So it might be useful to borrow it or take some lessons learned from it. With this whole speech in mind, I'd like to talk to you in the group about, you're talking about changing the packet format. I know I mentioned this last year. I think there's an opportunity to, I know you don't want to change all the code, but I would like to explore modifying the packet format, just the bits on the wire, so that you can take advantage of the other extensions that we've designed for the packet format, including security.
So I understand you're suggesting using packet BB for Babel.
Yes, and I would be willing to work with people in making that happen. I think it would be a win for everyone, at least to explore the idea.
So to give people some background, please stay in case I mischaracterize something. The Manet Working Group has designed what they call the generalized packet format.
Generalized building block.
Yeah, the generalized building block, which is a common packet format for all of the routing protocols designed by the Manet Group, which include OLSRv2.
We've also designed, they haven't been published, LoadNG and AirDVv2. They both use the packet format as well. So it's not just one protocol, they just haven't been published. I was just being mean.
I apologize. This generalized packet format is exactly the kind of thing that frightens me. It's a big document. If you include the time format and so on. And here I would like to keep so I'm taking the opposite approach. There are two ways of designing something that works. One is to do something that's fully general so that you only do it once. And one is to do something that is so specific and so simple that you don't mind doing it multiple times. And the latter is my approach.
My point is, I think it's worth exploring. I don't think it needs to happen, and it can happen independently of ongoing work. Being just the format of what's on the wire, conceptually, the protocol would work the same. Nothing has to change there. I would just like to talk to you and the group about it.
That's always fun.
The big advantage for this working group for using that you would get lots of things that I'm seeing up here, like extended TLV fields, compression of addresses. It does a lot of the things that you're looking to do, and I see the work happening again, that we put a lot of effort and thought into trying to get it right. And you would also get things like the security TLV and that sort of thing that would be helpful.
So I can make a comment. We actually have a fair amount of extra time here, so I don't think we're going to settle this, and I'm not suggesting this continue. With people welcome to comment on these issues on the list, but I'm not going to be too strict because I say we have extra time in this slot compared to the scheduled time for the presentations. And on a completely different thing, if I just make one comment on this particular slide, I'm just saying that you'll probably have difficulty with the security area in getting statically keyed, something statically keyed through unless there is a option, another method which has key negotiation, because that's statically. If you only have statically keyed version, it's really not considered to meet modern security standards.
Okay, so next, please. And I'll finish here. I think that we can start work straight away. So I'm going to most humbly request working group adoption of the RSC 6216. 6126.
We did that already.
It has been already done?
Yes.
Okay, cool. I didn't realize I had.
I did it earlier.
We need to integrate 7557, the extension mechanism. That's a lot of editorial work. That's a lot of meticulous editing to make sure that it still reads as a document. But from a technical point of view, that's not difficult. We need to fix the obvious bugs. We have a list. We need to implement any changes that we propose. Then we need to discuss them on the mailing list, and finally integrate them in the document in this order, and decide what to do about security. Thank you very much.
Comments? Yeah.
So I had two things. The first one is that
Who are you, by the way?
sorry, Dave Todd. You have a tendency to refer to the loop avoidance metric as the primary metric. And I think that confuses people. I will actually talk about the 16-bit primary metric as the loop avoidance metric, and then basically infer that we have another metric that is primary, or the one that's more consistently used. Okay. The second one is something of a procedural question. Is there a use cases document? Is there a need for one? Okay.
Yes, there is.
Yes, there is? All right. Good. All right. Okay.
So is a use cases document needed in addition to an applicability?
Go ahead.
So we're here for implementations. We're here for things that we can, OLIA Atlas. We're here for things that we can actually start, or continue, I should say, in this case, playing with. I do think it's important to have an applicability draft that describes the types of networks that it works well for, but the working group was specifically chartered with a minimum of documents that do not lead to code.
So Russ White, just doesn't matter whether my chair hat is on or not in this particular case. I think that use cases can be useful, but they don't need to be drafts. Okay? So if there's a wiki someplace that people want to put use cases on and to play with them and look at them and see them, we're all more than happy to read them, but we don't need to take them through the IETF process and get consensus and do those sorts of things just so that we can develop use cases, if that's a useful. I'll let you have the mic.
Justin Dean, in your presentation, you had a question about should you worry about duplicate IDs in this working group. From history of the AutoConf working group and where that led and all the different solutions you can do, I would suggest strongly against doing that work. Try to get another working group or some other way to solve that. I don't think it would be productive to do it in this working group. So I agree with you. I didn't hear you with regard to IDs.
John Daddle. I must admit the use case thing did go through my head when we were talking about security, because I believe that you can't really analyze your security threats unless you work out what your use cases are. It's a fairly standard thing. So, particularly the thing like static keys. I know that in Mono we've had some nightmares trying to work out how to do modern keying in ad hoc networks, and it's really difficult, but security IDs want something more modern, and there's a catch-22 in there somewhere. So I would strongly urge, even if it's a really short draft, doing some use cases to say, right, these are the use cases that we are targeting in this round of work in this charter scope, and then that gives the security ID something to work with.
Toki Harlan Jorgensen. I have seen the discussion on the mailing list previously about the different approaches to whether or not to increment the protocol number, and I think I tend to agree with you that we want to stay compatible, and I am satisfied by your list of solutions to the issues that I've run into, at least. And I think the conservative approach is the right place, is the right one in this case. At least for the beginning. And then a bit more strongly, I'm going to say that I don't like the idea of having the one true packet format to rule them all. I cannot, unfortunately, I cannot remember the name of the XKCD cartoon about standards that is relevant here, but I'm sure many of you are familiar with it. And I would not think that that would be something I would want to implement, at least.
Hi, I'm Rotana Cisco, speaking as working group participant. At the beginning of your slides, you talked about requiring implementation, requiring deployment experience. I don't have a specific objection, but what I want to clarify is whether that is a requirement for the working group. Different work groups do things in different ways, and not every work group does it this way. So I just want to clarify that.
No, that's not currently a requirement that's been set for the working group, either in the charter or by a consensus. I think it's I think that was intended to be a attempt to essentially set a pattern of the culture going forward, but not be an immutable rule or anything like that.
Right. Again, I'm not opposed to necessarily that. I love running code. It's what we need in more places. I just want to make sure that what is the bar, right?
I use the term tradition. I use the term tradition. This is the tradition I would like to see established in this working group. Now, traditions happen or they don't happen. I can always hope.
Okay, maybe with one more. I think we need to move on to the next presentation here.
Benedict Rudolph.
Yeah.
Regarding Justin's comment on the router identifiers, keep in mind that it's running on embedded systems that often do not have a real-time clock, which is often an input to some pseudo-random number generators. So you might end up with nodes that have a very bad entropy. And when you reboot multiple nodes, you can easily run into situations where you get router identifiers that are duplicates
So there's examples where that happened for other pseudo-random number applications. So you might consider that.
Do they typically have a burnt-in serial number or MAC address or both or something?
Yeah, but there may be bad versions of the firmware where it's all the same, and there were incidents in the wild where basically embedded systems are very prone to that.
Okay.
To that duplicate stuff.
Okay. So unless there's anybody who has something they think is really important. Oh, sorry. Okay. So, hit the red button.
Hello, this is Dennis. Can you hear me?
Yes.
Good afternoon, everyone. I would like to add that the running code is not only the tradition that would be great to have established in the working group, it's the tradition that has been around this development. So to reuse this would be great. And regarding the ways of changing the protocol encoding, it seems to me it would be great to make as little changes as necessary, but do make the changes that necessary. That is, before you make any changes, it would be nice to have a simple answer why we are doing this, not just for fun, just to see how it works, to experiment with it. There should be motivation. If there is no motivation, just leave the things working if they're working and fix something else that is maybe not working as well as it should be. And another thing, I have listened to the comments about security, and it would also be great to receive comments on my recent post to the mailing list, because there are things that if you could review and provide feedback, it would be easier to work. That's it. Thanks.
Okay. Okay. Thank you. Okay. So unless somebody else has something urgent, we should move on to the next presentation on information model.
And if someone else could jabber, scribe, you know.
Only if you give him the iTab.
Do you want control, or do you want me to do it?
Sure, I love having control. Okay, hi, y'all. I'm Barbara Stark with AT&T. So there's been some discussion about the need of an information model or a Yang data model as a deliverable, and so I figured I'd just go ahead and throw something out there. Now, my philosophy for what I was going to throw out there was go through the existing RFC and find everything that looked like it was even a remote possibility as something that could be thrown into an information model. Let's see, what did I say? Yeah. The only things I avoided were things that were truly ephemeral. That means, you know, they were like going to go away within seconds. So that didn't make any sense to be reporting even state about. Now, I did not include any of the other drafts. I did not include the 7298, which is that security RFC. The notation I took from an LMAP information model that's currently underway, just to have, you know, be consistent with something else going on in IETF. And I did not try to separate state versus configuration, which I know is done a lot in Yang data models, especially when I was looking at some of the Yang stuff being done for routing protocols. But that seemed like overkill at this point of the game, but we can certainly discuss that. From what I could tell in going through it, there's very little need for configuration, and my suggestion would be that incredibly little configuration should be supported. And and I don't think I recommend that any configuration must be supported. There's just a few that I think may be reasonable if an implementer chooses to allow configuration of those constants. And then there was one place where I did suggest a must, but it was only a must of if you actually implement this capability, then you have to allow configuration of it. But we'll get to the, or no, I guess we won't. No, we will. Okay, yeah. So this is kind of just an object hierarchy I put together. I had a block of constant objects because in the RFC there was a section on constants and it was great, and I could just go through the RFC. God, that was so easy to read, Julius. That was like weird. I could just go through it and see what all constants he said needed to be implemented. Then after the constants discussion, there's other discussions around information that implementations need to have. So there were some tables that it said that they needed to maintain. And so I figured, you know, I'm just going to throw all this in there. If they've got it, in theory, they could report on it. So let's just throw it out there, see if it sticks. And so I just put all that out there. You've got your interfaces. Within the interfaces, you've got neighbors and CSAs, and the interfaces should actually be to the left, tabbed. And then there were sources and routes. And like I said, I did not include the table of pending requests. Now, as I did this, I should say, I thought it was horrible. It's like way too much information. But I just went through the RFC and put everything that even made the remotest possible inkling of sense in there. And I thought it was a horrible thing, but it's a starting point because it shows everybody kind of the entire set of what I think is even remotely possible. And from there, it needs to be shrunk. Now, personally, I would shrink it like down to almost nothing. And I was really surprised when Julius said, oh, thank you, Barbara, this is a good start. And here's just a few comments because Julius, darn it, it was awful. And so I told Julius that and he said, thank goodness, Barbara, I'm so glad. That's really what I wanted to say. I think that's paraphrase. So we agreed. Okay, just some suggestions that I had. I briefly talked about configuration. These were some things that looked like they could be configurable parameters. There's the UDP port, which I actually got out of the profile that you were suggesting for HomeNet. And then I was looking, you know, these hello intervals look like maybe they could possibly, but I really wouldn't want to configure them. But what the heck, I threw it in there as a may, just so we could have something to throw at and talk about and see if it even made sense. And then there were thresholds. And then the one that I thought, you know, would be a must is the RFC talked about calculating costs and that there may be external costs that are input into the calculation. And so I figured, well, if there could be external costs taken into account by an implementation, then there has to be some way to input the external costs. So that's the one thing where I figured if somebody is actually implementing something that can take into account external costs, then you must implement a way to input the external costs. So there are two backup slides, but I thought I'd stop here. But if you like, I can show you the backup slides really quick, just so you know what's on them if you haven't looked at them. There's one where I actually I looked at what is going on in NetMod around routing data models, and I looked at kind of, okay, like where would this thing get slapped if it got created? Not slapped around, but, you know, like put. And so those are kind of the eye charts of what I found, and that's where I found that they separate configuration and state goes into another place, and it was like, wow. And so then I decided to go look up, refresh my memory, what's in TR69, and I just provided you some links. I didn't show you what it looks like. Well, there's kind of, you know, there's this object, and that's the name of the object. I went and looked at the one for RIP, which I figured, you know, this is less complex than RIP. And it really had almost nothing. You could enable, disable the protocol, and you could say whether or not to receive and whether or not to send RIP messages, and that was it. And so from a service provider perspective, it's like, yeah, that is pretty much all I'm interested in.
at the perspective of the home network, which is kind of to segue back to, oh my God, what I suggested here, this is like so way overkill. And really, you know, if I had a preference, it would be a lot more along the lines of this sort of minimal thing. Enable it, disable it, put 2, 3 parameters, you know, not a whole lot, and be done with it. But that's my thinking.
Julius Krobacek. So the reason I was,
Closer to the microphone.
Closer to the mic.
the reason I was trying to avoid saying how much stuff you should remove from this is that I have no idea what should be in a management model. And so I don't, what I can speak about is what our users are clamoring for. They want to do 3 things. They want to be able to remove an interface with 0 packet loss. So they don't want to down the interface and let the implementation reconverge. They want to tell the implementation, try to get rid, you're going to lose this interface. So they tell the implementation reconverges with 0 packet loss, and then they remove the interface. They want to be able to tell the interface, I've just created a new interface. Okay, so that's for people who are using Babel over tunnels. They've just created a new OpenVPN link or something, and they want to tell the implementation, hey, could you please route over that new link? And the third thing they want is the ability to disable the wired optimization in cases where they are bridging with a wireless bridge. Those are the 2 things that the 3 things that the users have been asking for.
Before you go away, so there's a difference between a management protocol and some of the things that you said the users wanted to be able to have control over, or what a management protocol can realistically do, because most management protocols are not expected to operate in sort of a real-time, especially not on home networked routers. And so if that link is getting ready to go down within the next couple of seconds, suggesting it be configurable to be told by a management protocol is probably not the best way to do that.
I believe you. I have no idea what a management protocol
So,
is.
but we can certainly discuss that. And so I'm thinking we may need other ways other than management model stuff to take care of what you're saying.
Right, Russ White, chair hat off. I do think that telemetry is probably going to be a bigger deal than people want to think up front. We always tend to start thinking, well, nobody ever really wants to do telemetry on this, so let's do something really short, simple, and easy. And then in 5 years, we need to do telemetry anyway because something else comes up where it's really important, or you actually have to troubleshoot, oh, did I say that? An implementation that's not quite right or whatever. And telemetry comes in really, really handy in those situations. You know, I run a pretty big network, and we don't like CLIs, even for troubleshooting.
Only Atlas, also no hats. So one of the advantages, for instance, there's Yang, one of the things about NetConf or RESTConf is the ability to do the communication in a reasonable, timely fashion. And there's also ideas around troubleshooting in the I2RS space, which Russ can also fill you in all about. But I think it's one of the things that is interesting to think about is as the troubleshooting, what can you turn on things with from the management side so that you start collecting more information or shipping it someplace, or given that this is going to be an unconfigured, unmanaged thing generally, right? That's one of the goals, is to have a protocol routing protocol, you just turn it on. The question would come, particularly from your perspective, you're trying to virtually manage this, what kind of things can you get some troubleshooting information out of, or in a more complex environment, what kind of troubleshooting information can you get out? And it's probably interesting to talk to some of the folks who have current deployments and play. Again, no hats.
And before you go, I'd like a chance to respond.
Of course.
We are talking about a home network environment. Let's be really, really, really clear on that. We're talking about itty-bitty little home network routers. We're not talking about the big things that do big things. Yes. So there is I am not aware of any plans to put netconf on any of these, and I am seriously unconvinced that I would ever want netconf on one of these. And as I've stated, the only router in the entire home network that I know to be managed is the one at the edge that is supplied by the ISP. And I think that if we try to have any dependencies on anything else, even having a netconf or TR69 or RESTconf interface, that we're dead in the water. And that's, telemetry, you're only going to get it from one router. NetConf, I don't even think is the right solution.
But Russ White Lincoln, I'll just say that don't underestimate the ability of grandma to outsource her network to somebody locally who has to do the troubleshooting locally. That's all.
And your point's well taken about considering what kinds of protocols, but there's a lot of discussion and investigation of options that can use different models. For instance, in R2GWG this time, there was discussion about gRPC, which doesn't belong in routing, which is fine, but they're looking at it for telemetry and also some types of simple commands. So it's not like it has to be something even vaguely as heavyweight as one might regard netconf in this context. The other point is, while HomeNet is and home networks are one of the main applicability, we shouldn't assume it's the only one.
Understood. And I
thanks for
think
doing
that's
the
right.
work.
And like I said, I kind of started from the throw everything out there. Hi, Margaret.
I think this is a really awesome start, so thank you. I think that there are some different things we're talking about here, right? One is the overall information model of Babel, which is not necessary. Then you decide what parts of that information model it makes sense to export via Yang, what parts of it makes sense to export via MIBs. I don't know. All cable modems are managed via MIBs, which is kind of exciting. What parts of it you want to export other ways, right? But I think it's good to capture the whole information model first, before you decide that Yang isn't going to want to do that, so we don't include it in the information model. I think there are a few things missing that would be really nice to have if you were trying to debug a network, and I agree there's some cases in which there's not really going to be somebody to debug a network, but the things Julius was listing sound like there are actual users who want to be able to more directly interact with these routers. I think you're going to want, in the routing section, you're going to want to include whatever information you have about who you got this routing information from. You need to think about, there might be actually two levels of tables in a way, or some sort of flag you're going to have to add, because we're keeping routes in Babel as backup routes that aren't currently the active route, and I think you're going to want to be able to see that pretty clearly in the routing table, and I don't see that there.
Well, there's an external routing table. Remember, these are just Babel-specific things, and this is not the routing table.
Well, okay.
Because the routing table has routes it gets from everything, routes that are static, routes that are...
Yeah, but Babel has a very well understood notion, at least, and we're implementing like a subset of it, and it has a pretty well understood notion of the idea that it's keeping some backup routes, and that a particular route is currently the active route for that destination, but that it has some stored information that you're probably going to want to be able to see, but not confused with, you don't even know which route's actually being used and what routes are just stored for backup. So I think you're going to want to put some information in there about that. Also, I think you might want to know what neighbor you got stuff from.
Well, and there was the sources and the routes and the neighbors.
Okay.
Those tables that Babel RFC describes, they're all there.
Yeah.
But if you want to know, there's no idea that Babel as an implementation should maintain the information as to this is what's in the routing table and these are the backups. There seems to only be, you maintain these routes and the routing table knows what's in the routing table.
I don't know. Julius is going to. Babel route selected flag. He's saying it's going to do what I'm asking. So apparently it's already there. So I didn't realize that was what that was. So it's already there, the flag, whether this route is selected as an active route or not. And so that's good. I also think there might be some counters we want in here or other statistical stuff. I don't know if Babel implementations currently contain any of that stuff. Often you end up with a bunch of stuff outside of the spec that's sort of statistics about the running code. And that might want to get somebody who, like look at least one of the implementations. I don't know, Julius, are there any things like that? No, in the implementation, are there any counters or other data collected to try to know when something's going wrong, like how many bad somethings you got or anything like that?
Julius Krobachek, there is logging, but there is no accounting,
Okay.
as far as I know, in any of the implementations.
And we might want to discuss whether that would help or whether that's a good thing, because it is often in other protocols, but I don't know whether there's just been no need for it or.
If I can just make a quick comment.
The log won't be shown though, see over Yang, or you could show the log over Yang. I mean, I don't know. Yeah.
There's widespread experience that home routers really hate excessive logging. Thank you. Yeah, they're very resource constrained little babies, and they don't have that much CPU compared to the big things. And if you turn on a whole lot of logging, they go ah. So then you have abilities to turn on and off logging, which consumers never use.
Tokyo Helen Jacobson. The only thing I can think of in what you mentioned is things like, when do I expect to send the next update, or when do I expect to send the next hello? And then as part of the neighbors object, you can also have, when do I expect to hear the next hello from this neighbor? But I think that's already part of it. So
well, and for me, that was some of where I was going with this ephemeral stuff, is that when those things are going to happen, I think you're counting in a period of seconds. And so you're not going to be polling this thing with netconf or with TR69 to get that level of knowledge out of it. And that's where I completely avoided or tried to avoid.
But I don't think there's any, like, at least, I don't think any of the implementations keep track of how many times have you heard in total from one neighbor or anything like that at all.
Yeah, when we put in the error handling spec, we may end up doing some things we want to keep track of when certain errors occur. Mike?
Oh, yeah. Margaret was making a comment, not at the mic.
Someone's at mic can repeat it if they want.
Julius Krobachek, Margaret's comment was that if we put in error handling in the spec, we might want to put in accounting too. My comment is that it's 2016. The smallest machines we have right now have 8 megabytes of RAM. Remember how much we had on our desk not so long ago? The smallest boards we can get have 8 megs of RAM. They all have the smallest CPUs you can get have a 260 megahertz CPU. I'm quite willing to add to a Babel implementation an integer somewhere, and then if something interesting happens, increment that integer. That's not at all a problem for the implementation. Statistics are good. Everyone loves statistics. No problem at all with that. I'm not sure that's something we want to put in the spec, though, or at least not in the base document, or at least make it optional. Okay, that is something that does not bloat the implementation much, but that is something that is likely to bloat the spec.
I agree. So often those things kind of aren't in the spec, but they're in the information model spec, right? Because if you want someone elsewhere to be able to see the value of that number on a running Babel router, you need a way to read it, right? So it needs to be in the information model. Because kind of the information model is everything anybody might externally ever want to be able to access about the running Babel instance, right? And so the information model might include, you see in, I can't just pull them off the top of my head, but like in MIB2, there's numbers of packets that appear to be lost. We detect we had a lost packet, we react to that, right? There's a counter. And it's not like that counter is in the TCP spec, but it is in the MIB for TCP. You understand what I mean? Because we want to be able to see it remotely.
But just to be clear, you're not suggesting that the routing protocol report on interface statistics, right?
No,
Okay,
no.
just checking.
I was giving you an example.
Okay, just checking.
That's so Julius Krobacek again. Something really cool to put in the implementation. Something very, I mean, if it's in the implementation, you could, I'm sure you can put it in a vendor extensions field somewhere. Every time you require accounting something, you are constraining the implementation. You don't know what is the cool optimization that we won't be able to do in the implementation, because the cool optimization means we no longer can account for this particular case.
Yeah.
You're also using memory and CPU to do it.
This is Donald.
It's not as trivial as you think.
If I could be virtually in the queue there, I would say that I think it's counters. It's good to say that you should keep a counter, not must.
You may.
No. Well, that's
No.
not too bad. But I like should myself. But all right.
So Russ White, LinkedIn, with your head off. Another point to remember is just because it's in the model doesn't mean that every implementation has to do it. Different implementations might find different pieces of the model more interesting and useful than other implementations. The model is supposed to be as complete as possible model of what you can actually measure and a way to get at that in any particular implementation. So don't think that because you have it in the model means that we've got to implement this in every implementation. It now becomes a must, blah, blah, blah. That's not the way it works. The reasoning behind the model is that if someone is implementing and they decide that they want to, in their implementation, measure something that no one else measures, there's a standard way written in a draft for them to do so. So if anyone else decides to implement the same thing, or they decide to do a RESTconf query into a device to see if that is available, they know where to look. That's all the models are really for. So let's not get too bent out of shape over models and how much memory they take and everything. It's totally optional stuff. It's just useful to have it on the table in case someone decides to implement it in some device that's larger than 8K or whatever. That's all. Whatever.
Are there any further comments or questions? It would appear not. Thank you very much for the presentation.
Very good. Thank you.
Yeah.
Oh, you actually returned our, you returned our clicker. That's very nice. And before Donald brings up the next one, I just want to point out that we are missing a draft. Given the history of this week, there must be a Babel and BGP draft somewhere in someone's head.
Yeah, I wonder what the date on that draft would be.
Don't you mean BGP and Babel?
Okay, moving along to our last presentation. Introduce yourself.
Yes. We need one, Teddy.
Hi, my name is Dave Tott, and I have been running deployed Meshi network protocol networks for well over 10 years now. Babel has been a primary routing protocol for my networks for over 8 years. And it was also part of a project I used to run called Saraward, which bled into the HomeNet working groups projects later on. So I have a very different philosophy since philosophy has been happening. My philosophy is to take a whole bunch of beta, broken, weird stuff, plug it all together and see what happens. And sometimes that works, sometimes it blows up enormously. So this talk was originally slated for the HomeNet working group because we're living in a brave new world today. Your primary computing device is a laptop or a handheld. How many here use Wi-Fi? Yeah. When was the last, how many here have plugged their laptop into Ethernet in the last week? I thought they didn't have it in the hotel rooms. Okay, well, anyway. Well, but my overall point is that The world is moving to primarily wireless access for almost everything. You have your cell phone talking over LTE out to the internet, and you have it talking to Wi-Fi, not just to the internet, but to your home network or your small business network. And I think that someday we will also be talking via some wireless protocols to things in the Internet of, otherwise known as LeperNet. Now, there is still one wire that's pretty common, and that's the wire that you get power from your devices. So it turns out that many devices actually need power all the time, duh. And other devices are battery operated and only need it part of the time, but they do have a wire. And it turns out that over the last 5 or 6 years, the micro USB OTG connector has become a default standard. And that happens to supply 2 amps and 5 volts. And upcoming is USB-C standard, which puts out up to 100 watts. And is a part of, for example, the Chromebook, Pixel, and the new Apple products. And we have a universal serial bus that's coming out that's capable of 10 gigabits over a distance of about 15 feet. And although I work on Wi-Fi, Wi-Fi sucks. We made a lot of progress on improving it. But at the same time, in coming up with this talk, I realized that what we wanted to do to truly make Wi-Fi fast is only use it when we need it to. So I went and started looking several years ago at various other ways to connect devices to the internet that weren't wireless. And I started with HDMI. You'll see here, this is a compute stick. This is a full-blown Intel PC. They cost about $80. They just plug right into your HDMI port, plug it into power, and you plug it into your keyboard, and you are fully functional. Let me just toss these things. You ready? Awesome. Feel free to pass that around. And then it connects to power over USB. And then it has an 802.11 Wi-Fi chip in it. That is, of course, hidden behind your television, which is a giant radiation shield and interference generator. This strikes me as being a little dumb. But I first went looking into why did Ethernet over HDMI fail. And what happened here is it was 100 megabits, but nobody could agree on how to use it with IP. There was parallel copy protection. We didn't know how to do address assignment. We didn't have a routing protocol that worked, and bridging seemed inadvisable for this sort of technology. And service discovery was already covered by the underlying HDMI protocols, so you'd be able to get to various devices on the network. Therefore, there was no demand, no standards, no market, and I don't know about you, but I still bought a whole bunch of HDMI-capable, Ethernet-cables anyway. Don't do that. But more recently, in the last few years, we have seen a resurrection of USB-Net. We've been able to run IP over USB since 1998. I'm not really sure when it entered Windows, etc., but I know personally, and I was using it back in 1998. Performance is extremely good, low latency, 20 to 200 megabits on USB 2. It coexists with all these other services, and it's used for USB tethering a lot. How many of you ever used USB tether? You know, it's cool. You're tethered and you can get out from your laptop, but you can't get this guy to go into your network over the wire. How many of you have also had a 500 megabyte download happen on your phone? Yes, so it would be good if that came in through a wire and left through a wire sometimes. And there are billions upon billions of USB ports. And can we actually make USB-Net a first-class networking layer, one capable of participating fully in an otherwise Ethernet network? And the answer is yes. So the thing is that getting at this stuff, getting at the enough layers to be able to make it a fully routable protocol, link layer, is a little difficult. So the hackerboard phenomenon started up a few years ago with the Raspberry Pi. And there's common operating systems of Debian and Android. There is actually Windows for the Pi. There's Minix, there's BSD, there are RTOS. They all have this basic capability built into them now. Many of these guys actually do not come with a gigabit 5, partially because they can't drive it and partially because it costs more and eats more power. This guy here is a quad core, 1.2 gigahertz, 64-bit box, which runs off of USB power and costs $40.
Are you throwing those or throwing them at people because they're sleeping?
I'll throw it at somebody else. You want one? Okay. And these are not just hacker boards. These are the chips that are going into the next generation of everything. Televisions, set-top boxes, IoT, handhelds, whatever. And yet they're suddenly accessible using standard operating systems, and we can continue to evolve them forward to do new and interesting things. They cost somewhere between $2 and $50. This one here is a box with Wi-Fi, gig of RAM, gig of flash. I'll throw it at somebody else. And USB only and Wi-Fi. You ready? $8 today. $9, sorry, it went up. And this is today. That's more power just through flying through the air than you can run like 100 Commodore 64 emulators on that, if you want. So when I went looking into, as I sat there, I plugged everything in. Let's see if I have a picture of that. There we go. I sat there, I plugged in all the different boards I'm throwing out today into USB. Turned on USB network and tried to figure out what worked. That is my network right there. It was one wire each just for power and Ethernet. And it turned out that it did work, but there were some issues. We have problems with address assignment, routing, and service discovery. There's also a fourth one, security. And the HomeNet working group has basically solved the first three and maybe a bit of the fourth one. The address assignment issues are pretty nifty. This guy here will supply a static IPv4 address space to your laptop in a default route on its own thing, and you can only go out. And you get another phone, the same brand, and you plug it into your laptop. It will also give you the same IP addresses, and you can only go out. So that's a problem. USBNet is a point-to-point bus overlay, and one of our problems here is trying to do address assignment, and we have a limited number of IPv6 prefixes in HomeNet, so we kind of need to be able to apply point-to-point addressing. There's a version of the HomeNet protocol, HNCP, which allows for smaller prefixes than 64. And even then, sometimes you're disconnected from the network, and still it'd be good to be able to talk to your device that has your pictures and stuff on it. So doing no relay assignment is not something that these guys currently do. In order to actually get full routability, you need to be getting DHCP PD from your cell phone provider. Several, I can't mention names, have talked to me about Sunday providing that capability, but none have got back to me recently. Slack does not work on less than 64s. DHCP does, and I should say HNCP does not, but the implementation of Julius's, which is called the small, stupid HNCP daemon, does. And it works today, so I can get full IPv6 routability and address assignment today on all these devices. And wow, so I got my IPv4 address, I plugged in, I turned on Babel, I installed it. apt-get install Babel, boom, I had full routability. No more work required. 30 seconds. I didn't expect that to happen. So you can take these things today and do that. Now it turns out that Anycast actually works, which is great. You can have a static identifier, and you can plug something into USB on any USB port in the network that just supports USB networking. It will announce itself, it'll exist, it's great. And the bad part is that if you are statically assigning from a single address space for multiple devices, then Anycast will pick the closest hop to whatever you're looking for. So again, doing better address assignment would help. The underlying stack in Linux goes and creates random MAC addresses. And that's okay, that's reasonable, and you can tie it down better. But it then turns out that current network daemons in Linux will rename the device according to the MAC address. And there's no way to deal with that. And they're really, really long. They're not designed for humans. Not useful. And there's this thing called Network Manager, and Linux is a pain in the butt. Lastly, on this side, Babel's own link costs are calculated the same no matter the link layer. So we have a USB networking interface that's capable of 20 megabits or 200 megabits, competing against Ethernet for 10, 100, 1,000, gigabit, whatever it turns out to be, as well as any other link layer technologies. The principal aspect of USB is it occasionally has a bit more jitter than Ethernet, and it is slower in current USB 2 standards, and soon to be 10 times faster than normal Ethernet. Again, this is a HomeNet thing here. Doing service discovery over MDNS works over one hop. Always works now. However, there's additional work for a hybrid proxy for MDNS as well as subscriptions for DNS, which is not quite completed in the working group, and there's not that much working code. If you're crazy enough to start getting these little devices and plugging them in, it helps to actually power them from a USB port, from USB 3 port rather than USB 2. One of my favorite parts about this, again, I just plugged it in. The next thing I did was I ran a benchmark, and it turned out that the FQ-Caudal AQM algorithm just worked. I don't have to do any more work to make USB work. I am happy. Wi-Fi is killing me. And so now that I had all these different devices working, I said to myself, okay, so great, I'm a hacker, I'm building on hacker boards. These are chips going into absolutely everything. How can we move forward the state of the art? Well, the next steps were going to be to try to make it work on something like Android or Chrome OS. And I actually pinged Lorenzo over there via email last night and said, what do I need to do? And I'm hoping he can jump forward and tell me, do we need to rewrite all this stuff in Java to work on Android to access the routing tables and address assignments? Okay, he is nodding, no, awesome. But some of this stuff is GPL, Lorenzo. So is that a problem in the current Android environment?
Lorenzo Culidi, I'm not a lawyer. My limited understanding is that we can't link to GPL code. We can fork an exec GPL code. And if we make any modifications, they have to be open sourced, just like we open source everything else. We should. People have been asking for server mode, or for client mode USB Ethernet for years, and it never quite made the cut. But this could be sort of a more general sort of device-to-device framework, actually. I don't know, maybe it's time to look at it. One question I had is, what do? You turn it on and you get ULAs and that's it, and it's done? Somebody generates a ULA and everything talks together?
If I turn on HNCP and I have a server somewhere providing prefixes, I can get anything. However, in the case of a device coming up for the first time, it comes up to 192.168.1.1. But it is not successfully, it should automatically be declaring a full-blown ULA for itself, and then export that into the network as a default. Otherwise, it would be completely unreachable. And that's what OpenWRT routers do today. They just create their own and carry it around.
That's talk of fine.
Okay, thank you. We have, this stuff just works with OpenWRT. You plug it into the router, you get power, you get the devices online. Same thing, the Debian support is a little bit less there. OSX is only missing source-specific routing support, and I'm hoping that an API arrives for that. Windows, I know nothing about, and iOS, I know nothing about. If there's anybody here that would like to know the status, has the status of HomeNet for iOS or those two operating systems, that would be great. The latest one. Oh, sorry, Apple's stuff. You know, again, I'm holding one of these in my hands. I would love, of course, to see, to me, when I have this power and Ethernet distribution bus, I'm not typically going to be plugging that in the back of my 9000, you know. But I am going to plug it into my laptop, I am going to plug it into my router or my television or something like that and be able to want to get network functionality. Go ahead, Barbara.
So just to clarify that is Polish support for OpenWRT and not that you need Julian to create Polish support. Is that right?
Oh, that wasn't.
Just checking.
Thank you. Yes, we tend to just polish it some more. Okay.
Yeah, David Skenazi, Apple. So yeah, the Apple iOS has a tiny I, makes it easier.
Sorry.
Any case, now, in terms of support for OS 10 and iOS, yeah, we're missing a few key system components, and then we're looking at other parts. Yeah, you can't write your own app that does that on iOS because we don't expose this unless you're root, like most operating systems. But we're looking into it.
Okay. Well, we do have Babel running on OS X. I have not actually tried to get the HNCP code running on that, but Babel runs great there, as well as working with USB.NET.
Oh, and I've gotten Babel running on an iPhone, and it runs great there as well, as long as you have the custom internal builds or an agile broken device.
Really?
So Dennis wants to talk, I believe.
Hello there, do you hear me?
Good to see you, Dennis.
Thank you for the slides. It was interesting to actually see it from a slightly different angle. Excuse me if that sounds like a stupid idea, but I think if USB is a serial bus and if the connection is point-to-point, maybe in this case it would make sense to remember how internet was running like 15, 20 years ago, and remember that there was such a wonderful thing on a serial connection with no service discovery, no built-in ways of address assignment, and it was called PPP. And once you start your modem and your modem provided a more or less transparent connection, there would be a thing sitting on top of it that would be called PPPD, and that thing would handle all the discovery, addressing, and options negotiation. Maybe that old style approach would help for this new modern serial bus. How do you think?
I can believe that we can also improve the upcoming USB-C standard, if that's one of the ways we can go. I mean, 10 gigabits on your desktop, you're not going to see higher speed Ethernet in the home or small business anytime soon, I don't think.
All right, I can drop you an email if you want later, not to spend the time. Thank you.
Thank you, Dennis.
Julius Krabacek, could you go back by 2 slides, please?
This one?
Yeah, this one. No, it was the one before. I'm sorry. No, I've lost it. There is some point at which you've implied that we subnet beyond 64 bits.
For a point-to-point link.
So I would like to say that we would never do something like that. Subnetting beyond 64 bits. I mean, I sometimes do it, but then I turn all the lights. I turn all the lights. I close all the windows. What we are doing here is assigning a 128, a single address, doing no subnetting at all.
Yes.
And just doing pure mesh routing.
Yes.
Which is slightly different than general subnetting.
All right, that's correct. Yes, sorry. Go ahead, Lorenzo.
Why not just 127?
I could. I just didn't have support for it. And I have support for 128s right now.
Because 127 is actually a valid subnet length in the IETF standards.
Okay.
Whereas, like, for example, 126 is not.
Okay. All right. I have 1 slide left, or 2 slides left, I think. I also wanted to point out that hacker boards are fun. Oh, go ahead, sir.
This is Alex Petrescu. So I'm happy, very, very happy to see this IPv6 over USB discussion and /64/127, 128. You are calling it a point-to-point link.
It's essentially that, yes.
I was wondering whether if you put a hub, a USB hub, is it going to be something else than a point-to-point link? Like many point to many points.
I always do this. I have on that picture, I've had as many as 8 different point-to-point USB links.
So they are each still a point-to-point link. Each one is still a point.
There's no conception of real multicast inside the USB standard. You have to negotiate the connection for the USB stuff, and then you have a point-to-point link only. So any routing that happens has to take place on the connected host.
Okay. Okay.
Yes. Again, wow, USB-C, 10 gigabits. Let's make that better.
Yeah, I think all these questions also come out because there is no IPv6 over USB specification. We
Yeah.
rely on this USB net driver, which is there for many years, but there is no specification for how this should work, I think.
Okay.
Thanks.
Well, maybe there's specification, but it did work. It was shocking. It worked the first time. Yes, works locally in my setting. Absolutely, I agree with you. Last up is very simple, and I had an open question because it's not really in the charter. Billions and billions of ports, 10 gigabit capability, and what we have here is what we have is enormous potential, enormous powers. I'll look you up. 80-bit connector space. Get that one reference. And I would really, really like to offload Wi-Fi to USB and establish full connectivity to this particular stack. But there are many other potential new link layers that Babel could leverage and be able to communicate over and try to make better decisions. In the case of a cell phone, you have LTE would be my last choice, Wi-Fi would be my next choice, and USB would be my primary choice when available. Go ahead.
So by this, do you really mean non-Ethernet?
Yeah, non-Ethernet would be the way of presenting it, sure.
Okay. Oh, Barbara Starr.
There's no Ethernet switch in these designs, no?
Tony P., we already have IP over avian carriers. It can't be any worse.
I was going to reference that in this talk, but thank you for bringing that one up. But there are many, many, many other link layers out there that have their own specific problems. Powerline is one of them. I know a lot of people that will get their internet on one side of the house, they plug it into a powerline adapter, it ends up on the other side of the house. I would again prefer to choose a direct Ethernet line over the powerline interface. Go ahead.
Well, and that was kind of my question about Ethernet MAC. Bluetooth doesn't use Ethernet MAC, 6-low doesn't, but HomePlug does, G.hn does. And so you already have support for the HomePlug and the G.hn powerline stuff. You just don't have support for maybe X10.
Yes, yes. I agree that we do have good Ethernet-like layers. But we don't necessarily measure the quality of those layers at a level that we need.
Well, here's my challenge about that is usually when we're running these powerline technologies to the router, they look like Ethernet because we connect them to a bridge and all the router sees is Ethernet, and then you've got the power line beyond it. And my extreme concern is I hope that Babel is going to be able to tell that, this isn't behaving exactly like Ethernet, so maybe I need to treat it just a little bit differently because it seems to have a little more delay, it seems to have a little more loss, something like that. And so, hopefully Babel over anything with an Ethernet MAC isn't going to assume it knows what that connection is just because of what it sees at its port.
We do see this bridging issue today. Bridging with Wi-Fi and Ethernet's a problem, and bridging over power line is a problem with all technologies.
Oh yeah, Atlas. So how to do IP over different link layers is really a problem that the internet area solves. And I think it is important to decouple. Well, while it is excellent and very interesting to hear how it comes together as a whole system and to understand what the pieces of the problem are, I do think we need to keep the problem decomposed and focus on the part that we need to do here. We did set complex metrics out of scope for the initial charter. That doesn't mean that having good discussions isn't useful to understand or see what types of information might be useful to have, but but we've got some basic work to get done first. So it's very interesting, and if there are specific link layers that it's important for the internet area to, or that it might be useful for the internet area to work on, I'd be delighted to introduce you to Suresh. If you don't know him already, I'm sure you do. But we do need to keep the pieces decoupled.
Julius Krobacek. I have 3 comments about this discussion. One is that so Babel is, so you have to distinguish between 2 things. One is the amount of packet loss that different layers have, their behavior of radio interference and so on. And the other one is the MAC format. The MAC format is absolutely irrelevant to Babel. Babel runs over IP, over IPv6. What MAC layer is beneath it is not its problem. Just as Alia said, that's not our business, that's next room. The other thing is that we must distinguish between Babel, the protocol, which this working group is about, and BabelD and BirdBabel and PyBabel, which are the implementations. There are some things that Babel should not be doing, but that BabelD might do. One is, for example, finding out that this particular interface is a wireless interface. That's not part of the Babel routing protocol, which is a routing protocol. And my third point is, what about metrics for interesting interfaces? That, I could be wrong, but I believe that's something that has not been treated in a comprehensive manner by the IETF. There are bits and pieces. If you look at ISIS, in ISIS, there is a bit that tells you, or in one of the extensions, I don't remember, that tells you that if you're running over a 100 megabit Ethernet, the metric of the link should be so and so, and if you're running on gigabit, reduce it to so. If you look at the money space, there is some interesting work going on. Notably, I'm a big fan of Henning Roge's DAT metric. There are people in this room who have been doing various work in various routing protocols, such as Batman. I don't see the BMX7 people. No, he isn't here. But there has been some work, but there is no comprehensive place. We're not going to solve that problem in the first time within the Babel working group. What I would like to see in the Babel working group would be a main document that says, we accept, we can work with any metric that has the following properties. An informative appendix or an informative draft that says, by the way, those 3 metrics we have found work well in such particular circumstances. And some experimental work that says, hey, we've got this exciting new metric, we need more data.
So, let's just individual here, and it's not actually directly to address your talk, but more as we're talking about the system. One of the things that may be useful is to sort of articulate what protocols or pieces of system we're expecting to do different parts of functionality. One of the trivial, for instance, is that a standard IGP does is to verify that you can send packets at the max MTU, right? That's not something that's in Babel today. Now we can talk and say, we don't need to do that because it's handled here. We can say, we don't think that's important because it's never an issue. That would be a really interesting technical discussion. We can say lots of different things. That's just one that I noticed when I've read this spec, in the past. And so I think would be really interesting to sort of sit down and talk about some of what the functionality that a routing algorithm does in IGP, and see if there are other gaps or other pieces that we need to talk about and understand sort of how it fits into the broader architecture. I mean, you're talking what's underneath and the links, but there's a lot between that and being done with the routing.
I have one last point to make. This is in following with Julius's preference for actually writing code and deploying it and testing it. Unlike other protocols like BGP, you can go and deploy Babel on a bunch of boxes that cost less than $8 a piece today. and be able to do whatever you want with it. So I strongly encourage people to experiment and build their own networks and find the edge cases that way. Thank you.
Real quick question. So you passed around all those things. Does that mean that like on the LEDI or the OpenWRT, there's loads for those for?
This is all Debian. You could,
All the
this, for example, this guy here comes preloaded. You're done. We didn't need to do any work. OpenWRT is much harder. One of the things I'm working on, this is IP over sonar.
Okay.
Okay. Thank you very much. So that's the last presentation here. So we actually ran well over the estimated times, but within our session time, which, oh wait, because we had plenty of time here. People should, if they have thoughts on any of the issues that have been raised here, commenting on the mailing list is the way to go. We'll be, I'll be checking with my co-chair if we want to actually do any, civic consensus calls on any of these specific issues, but discussing them on the mailing list is a good start. And I guess we will see or hear people either physically or remotely in Seoul, Korea next time. And hopefully a lot on the mailing list in between. And if it's is thought useful, we can have interim telecommunications before then, which we may need to. Anybody have anything else they'd like to announce or anything like that? Anybody who has not put their name on the blue sheet should come up here and do so. But other than that, I believe we're done. Yeah. Yep.
I'm just kidding, it's fine, of course.
So I want to.